Yesterday we learned how to describe our data for x and y values for discrete data. Today we're going to work on describing our data using continuous data. So when we were describing discrete data, we were using braces and listing all the x values for domain and all the y values for range. For continuous data, because it's every possible value between two endpoints, we will be using inequalities and making an interval of the boundaries. The thing that you do need to know or remember is the difference between the open circle and the closed circle. So open circle, that means that the point is not included, is going to be your less than sign. Also could be the greater than sign. There's no equals to, so the point's not included. The closed circle does have the equal to sign, so less than or equal to, or greater than or equal to. So closed circle is going to have the equal to sign, open circle is not. As long as you can remember that, and remember Dolar the robot. Dolar is the robot that reminds you that domain, that's the D in her name, is read from left to right. So Dolar is just really saying domain is read from left to right. And the robot, range. Range is read from bottom to top. So when you remember Dolar the robot, what you're really remembering is how to read your domain and your range. So let's look at number 1. We can see how we describe our data for continuous data. So the way we do it, domain is read from left to right. So we're going to write down our left boundary, which is a -2. And we're going to write down our right boundary, which is +3. So we've just started. Domain is always x, so we're going to put that right in the middle. So what we're saying is our domain is all the x values between -2 and 3. Now the other thing we have to do is say, are we including -2 and are we including +3? -2 is a closed circle. We are including it. So we will go ahead and put a less than or equal to sign. And +3 is an open circle, so we'll just put a less than sign. That's how we describe our data. Now, one question I get sometimes from students is it always going to be less than? As long as we're writing it in an interval starting with your smallest number and going to your largest, we'll use less thans or less than or equal tos. The only time we ever use greater thans is if I had just said something like number 3, which is all numbers greater than -5. But when we're doing this in between, we're writing smallest to largest, so we'll use less than signals. Okay, number 2, I want you to do this one on your own. So you're going to find your left and right values and decide open circle, closed circle. So pause your video, do number 2, and then check back for the answer. Okay, that was very straightforward. You should have gotten it fine as long as you can remember open circle, closed circle. All right, number 3 is a little different. Number 3, we have a left boundary, which is -5, but we don't have a right boundary. This one's going on forever. So I could go ahead and put it as forever. Forever is infinity. And the question is, can we ever reach infinity? And no, you can never reach infinity. There's always one more number. So we're just going to have a less than sign. The -5 is included, so we'll do less than or equal to. Now, what we've noticed is a lot of times on tests, they don't write infinity like this. They will just say, well, you know what? It's every number greater than -5. So they'll write it like this. X is greater than or equal to -5. Those are the exact same. I just want to make sure you understand when you're looking at them, they are the exact same answer, and you could see it either way. Okay, now let's talk about range. So Dolar the robot. Dolar was left to right for domain. Range is bottom to top. So range, we're going to be looking at our bottom interval to our top interval. Again, that's going to be smallest to largest. We'll use our less than or equal to. So on number 4, we've got our bottom number, which is -4. And we've got our top number, which is 5. But this time, we're not talking about domain anymore. We're talking about range. Range is the y-axis. So we're going to put a y in the middle. And on number 4, both of our points are included, so they're both going to have the equal to sign on them. Okay, I want you to do number 5 and number 6 on your own using what we had learned on domain to do the range. Pause your video to do this and then check back for the explanation. Okay, those were very straightforward. Hopefully you were able to get those without any trouble. But now let's just take it one step further. We were just looking at our x and y axis to do those, to give you an idea of how it feels, but now our lines don't normally run up and down the x and y axis. But I want you to think along the same lines. So we're going to start on number 7 with domain. Domain is our x-axis. So I'm going to go ahead and just draw it on the x-axis. Let's go ahead and make this bigger. So I'm going to draw it here on the x-axis. So I got my closed point, and I got my open point. And there's all my lines. So I've really just taken my graph and put it on the x-axis to make it easier for me to see. So my left boundary is -4, my right boundary is 5, my left is included, and my right is not. Same idea on the range. So I'm going to go ahead and just come straight over here and draw my point on the -2 because that's where it comes to on the y-axis. And then I'm going to come straight over here and draw my open point on the 3. So that's really what I'm looking for on the range. So bottom point is -2. Top point is +3. We're on the y-axis. And the -2 is included and the 3 is not. So that's the way to deal with a graph. Just draw it over to the x and y axis and do it just like we did the earlier ones. All right, so let's look at number 8. So go ahead and pause your video and do number 8 and then check back for the answer. Okay, that was pretty straightforward. I do find it easier if I go ahead and draw straight over to the x-axis or straight down to the x-axis and straight over to the y-axis. I do find it is easier to get my full boundary in that way. Okay, number 9. Number 9 is an interesting one, and I think it's an interesting one for you to try on your own. I think you'll do fine on domain, but range is a very interesting answer. So pause the video, do number 9, and then check back and see how you did. Okay, most people have no trouble with the domain. The weird one is the range. When I look at my point, it only touches the y-axis. My line only touches the y-axis in one spot, in one point. So my answer is not a range, or is not an interval. There's nothing in between. It only touches the y-axis at 3. So my range on this is y equals 3. All right, number 10. Number 10, and sometimes it helps to see number 10 for a couple of reasons. First, we're thinking about our boundaries. So when I'm looking at my boundaries, it's very simple to see on the x-axis that I'm going from here to here. And on the y-axis, I'm going from here, but I don't have an endpoint up here. And sometimes students get confused on endpoints. But we're not talking endpoints, we're talking the very top of our graph, wherever that is. So when I draw the top of my graph over here, I think that'll make it a little easier to see what your x and your y domain and range are going to be. So now that I've done this, kind of given you a hint, I want you to pause your video to do it and then check back for the explanation. Okay, so the big things to keep in mind are the actual scale on the range. The scale on the range Each box is worth 10, so we're going all the way up to 60. So 0 to 60. Also, we don't have any circles, so how do we know if our 60 is included or not? And the answer to that is, as long as it's a solid line, it's included. If it were a dotted line, it would not be.